Hi, myself Dr. M. Tirupati, presently working as Associate Professor in the Department of VCE. Now today I am going to discuss about the topic is rectifiers and filters. So what are the advantage of the rectifiers? What are the advantage of the filters? So what are the different types of filters? So here today we'll see. So what is meant by rectifier and what is meant by filter? So what are the different types of filters? So everywhere in our home or any industry, so here only AC power supply is available. So now here, but all electronic devices needs only DC power supply. So daily we are using wristwatch and mobile phone also needs only DC power supply. So now how to convert this so that AC power supply into DC power supply? How to convert that AC power supply into DC power supply means, so here this is a basic block diagram. So this is a power supply block diagram. So how to convert this so that alternating current into direct current? So what are the components so that are required? So this is a total block diagram. So here if you apply AC input voltage, so that will be converted into DC output. So these are the block diagrams are there. So these are the different types of blocks. So what are the uses of the each block? So first section is nothing but a transformer. So what is the use of the transformer? So what is the use of the transformer means? So here two different types of transformers are there. So here now step up transformer and step down transformer. Now here if we AC input means, so that is nothing but a high input voltage, so that is nothing but a 230 volts. So that 230 volts is applied to the here we are using step down transformer. If not increasing the voltage level, so here we are decreasing the, so this 230 into DC voltage means, so that maybe so 15 volts or here 5 volts depending upon our requirement. Now here step down transformer we are using here. Now here this 230 volts is converted into, so again less voltage, so that will again apply to the rectifiers. So what is the basic definition of the rectifier? So what is the basic definition of the rectifier means? So this rectifier it will be converted into, so AC into pulsating DC, not pure DC. It converts AC into pulsating DC. So now here different types of rectifiers are there. So half wave rectifier, full wave rectifier, and here bridge rectifier. Now here what is the use of the smoothing? Smoothing it is nothing but a filter. Okay. Now we are using different types of filter: inductor filter, capacitor filter, LC filter, multiple LC filters. So what is the use of the filter means? If any unwanted components are there, AC unwanted components are there, using this filter, so that will be reduced. So now here final step is regulator. What is the use of the regulator? What is the use of the regulator means? So we are expecting here constant DC output voltage. If it is temperature changes or anything load changes means, so here that output voltage should be constant. So that's why we are using regulator. Now this is the basic block diagram. So here my present topic is rectifiers and filters. Now here introduction of the here, what is the basic definition of the rectifier? What is the basic definition of the rectifier means? Rectifier it is nothing but a electronics device, so that it can be converted into AC into pulsating DC. Okay, so AC into pulsating DC. Now here what is the use of the filter? Filter means, so here that will be smooth the DC output voltage. If any AC components are there, so that will be, so output should be, so that should be DC. Now this is the first basic block diagram of the half wave rectifier. So what are the different types of half wave rectifiers meant? So differently, so three types of here half wave rectifiers are there. So three different types of half wave rectifiers are there. What are the three different types of half wave rectifier meant? So here that is nothing but a, so here half wave rectifier. So half wave rectifier, half wave rectifier and full wave rectifier and bridge rectifier. First half wave rectifier, what is the basic operation of the half wave rectifier? What is the basic operation of the half wave rectifier? Now here what is the basic operation of the half wave rectifier means? So in the half wave rectifier major component is, that is nothing but a diode. Okay, so diode and a transformer. So what is the basic, so here circuit of the here half wave rectifier? So this is nothing but we are using step down transformer and diode and load resistor. So these are the three main components. So here diode and here we are using step down transformer. Step down transformer. So what is the use of the step down transformer and what is the use of the diode? So we'll see. Now here input voltage, so how much voltage? So 230 volts input voltage, and here 50 hertz frequency we are applying, so that to the transformer. So now we are using step down transformer. Step down transformer means, so this high voltage is converted into low voltage. So now high voltage is converted into low voltage means, so that's why we are using step down transformer. Then after here, so that step low voltage, so that will be again applied to the diode. So what is the use of the diode? What is the basic definition of the diode? What is the basic definition of the diode means? So here diode, it is nothing but it conducts only in one direction. It conducts only in forward bias. It does not conduct in reverse bias. What is the internal structure of the diode? What is the internal structure of the diode? So this is the internal structure of the diode. So now here this is nothing but a diode symbol, plus and minus. Okay, one p-type semiconductor, one n-type semiconductor, so both will be combined means, so that will be acts like a diode. Now here what is the property? So whenever if it is connected in forward bias means, so here this diode will be on in forward bias, so the diode will be on. In reverse bias, so the diode will be off. So in the forward bias, so the diode will be on. In the reverse bias, so the diode will be off. Now here this input voltage, so this AC voltage is applied to the diode means in the positive going pulse, so here the diode is on. So the diode is conducts. Okay, so diode is conduct means it acts like a short circuit. So diode is conduct. So this is the positive off cycle means, so this is the output. Now coming to the here negative off cycle. So negative off cycle means, so here the diode is reverse biased. So the reverse biased means, so here the diode is off state. So the diode is off state means, so that will be acts like an open circuit. So that will be acts like an open circuit. So again next coming to this pulse means, so now here this pulse, again here this will be displayed. In negative going pulse the diode will be off. In the positive going pulse, so the diode will be on. So this is the output of the rectifier circuit. So this is the output of the rectifier pulse. So now here this is not pure DC. So this output is not pure DC. So this output is not pure DC. So this is pulsating DC. So this is nothing but a pulsating DC. Now what we are doing here, so input voltage means, so that is nothing but 230 volts we are applying. So 230 volts high voltage we are applying. So the output of the here rectifier means, so that is only the positive going pulses only. So this is positive going pulses only. Now here positive going pulses means, so here what is that one? So next one, what is the waveforms of the that one? Now same circuit diagram, so primary transformer and secondary transformer. So this is nothing but a step down transformer, diode and load. So this is the basic operation of the here AC supply. Previously we applied here according to this diode. So here this is the pulsating output. So this is the pulsating output. Next, what is meant by ripple factor and what is meant by IDC and what is meant by IRMS. So now here output voltage is, so here what is, how to calculate the IDC and IRMS or VRMS and VDC. Now how to calculate that one? How to calculate that one? So what is the output of the here rectifier means? So this is output of the half wave rectifier output. So here output of the half wave rectifier. So output of the half wave rectifier means, so now here 0, pi, 2 pi, 3 pi, like this. This is output of that one. Okay, time period. Now here how to calculate the half wave rectifier parameters. What are the parameters means? So what are the parameters? IDC or IRMS or VRMS, VDC, how to calculate VDC and VRMS. So here efficiency of the, so this rectifier and ripple factor, these are the parameters. So these are the parameters. So TUF. So these are the parameters. So now how to calculate so here these parameters, how to calculate this parameter. So this is the output of the rectifier, so half wave rectifier. How to calculate the VDC, how to calculate the VDC. So actually here VDC means, how to calculate means, what is the complete cycle. So this is nothing but a 0 to pi, it will be on state. So now here pi to 2 pi, so that will be off. Now totally here how to take that one VDC, how to calculate. So here 1 by 2 pi, so this is complete total period is, so here 2 pi means 1 by 2 pi. So but here what is the output? Only 0 to pi only the output, pi to 2 pi, so output is 0. So you can take, so that is nothing but a 0 to pi only, okay, 0 to pi only. So now here 0 to pi Vm into sin omega t dt, sin omega t into dt. So here this is nothing but a sin omega t into dt. So what is the final answer? So after 2-3 steps, so 2 pi, so Vm is coming to this side, so here 0 to pi, so sin omega t means, so that is nothing but a minus cos omega t, minus omega cos omega t. So here equal to minus Vm by 2 pi minus cos omega t means, so what is the value of this cos omega t? What is the value of the cos omega t? What is the value of the cos omega t? So whenever if you substituted, so pi and here 0, what is the final answer means? So here VDC equal to Vm by pi only. Okay. After this next step, so here cos omega t means, so that is nothing but a minus 1. Here also here minus 1. Okay. Cos 0 it is nothing but a 1. So here whenever if you simplify, minus into minus plus, Vm by 2 pi into, so here also 2. So the 2 will be cancelled. So final output is Vm by pi. Vm by pi. So now coming to the VRMS, how to calculate the VRMS? So now how to calculate the VRMS means, so root mean square value 1 by 2 pi into, so 0 to pi, so Vm square sin square omega t dt. Okay. So now here root mean square value means, so that is nothing but a AC component, AC voltage. How to calculate DC voltage equal to how much? So that is nothing but a, so here DC voltage means Vm by pi only. Okay. Whenever if you simplify this one, whenever if you simplify VRMS means, so here what is the value we will get means, so that is nothing but a Vm by 2 only. Vm by 2 only. Okay. Now 0 to pi only the, so that is nothing but a output. So here AC means, so Vm square sin omega square t. So sin omega square means, in place of sin omega square means you can substitute. So here sin square theta means, so that is nothing but a 1 minus cos square 2 theta by, so here 2. Okay. So 1 minus, so here that one. Now here coming to the, so VDC equal to, what is the value we got? So VDC equal to Vm by pi, VRMS equal to Vm by 2. Okay. VRMS equal to Vm by 2. Now here these are the, how much of DC voltage, how much of here VRMS. So how much of DC? DC means Vm by pi. So now VRMS equal to Vm by 2. Okay. Vm by 2. Now here how to calculate the off-wave rectifier efficiency? How to calculate the off-wave rectifier efficiency? So what is the advantage of the efficiency? Efficiency means how much AC power is converted into DC power. How much AC power is converted into DC power. So off-wave rectifier, how much of AC power is converted into DC power means, what is the formula? Means how much of here DC power, what is the formula efficiency means, how much of DC power delivered to the load, how much of here AC DC power delivered to the load, and how much of here AC power, how much of AC input power, AC input power. Now here efficiency means, whenever if we calculated the efficiency, how much of DC power delivered to the load means, so that is nothing but, so here PDC by PAC, PDC by PAC. So how to calculate the PDC and how to calculate the PAC? So how to calculate the PDC means, so power equal to what here, power equal to PDC equal to VDC into IDC. VDC into IDC. So power equal to what here, V into I. Now we are calculating DC power means, so here VDC into IDC. Now here IDC means, so VDC into IDC means, so here VDC, that will be converted into, so here that will be converted into, again here voltage. So now here PDC equal to VDC into IDC. Now again here this IDC means VDC, IDC means, so here VDC by RL. I equal to what? V by R. I equal to V by R. So now here what is the equation? So here VDC square whole square by RL. So previously we calculated, so here what is the value of the VDC. So VDC equal to means Vm by pi. So now this is nothing but a Vm square by pi square, Vm square by pi square into RL. This is the VDC value. Okay. Now, so here PDC value equal to how much? Vm square by pi RL. Now, same thing if you calculate, so PAC. PAC means, so here PAC equal to same thing VAC into IAC. Okay. Same thing we can calculate the here VAC into, so here that one. Now, same thing if you calculated, what is the efficiency of the half wave rectifier? What is the efficiency of the half wave rectifier? Whenever if you substitute these PAC and PDC value, then you will get the what is the efficiency means, so that is nothing but a 40.6%. Okay, whenever substituted that value, so here this Vm square by pi square RL, and here whenever so VAC means, so that is nothing but a VRMS. Okay, so VRMS into IRMS. So whenever is that value substituted means, so what is the answer you will get? 40.6%. What is meant by 40.6%? What is meant by 40.6% means this 40.6% of the AC input power is converted into DC. 40.6% of the AC input power is converted into DC. So this is the biggest disadvantage. Only 40.6% of the AC input power is converted into DC means, so this is the biggest disadvantage. So now here, how to overcome this disadvantage? How to overcome this disadvantage? So this is one of the parameter, efficiency is less. So this is the disadvantage means, so here this is the one of the disadvantage. This is the disadvantage of this circuit. Okay. Now coming to the here ripple factor. So what is meant by ripple factor? So what is meant by ripple factor? What is meant by ripple factor means how much unwanted components are there in the output. Now ripple factor, how to calculate the ripple factor of the half wave rectifier? So how to calculate the ripple factor of the half wave rectifier? What is meant by ripple factor? What is meant by ripple factor means how much of AC components are present in the output. How much of AC components are present in the output. How to calculate the ripple factor? Ripple factor equal to what is the formula? Under root. So here VRMS by VDC whole square minus 1. VRMS by VDC minus whole square 1. So VRMS means, so here Vm by 2 you can substitute. So VDC equal to Vm by pi. Whenever if you substitute here, what is that one? VRMS means, so here Vm by 2, VDC means, so Vm by pi. Whenever these values if you substituted after simplification, so here what is the value? 1.21. So ripple factor value is 1.21. So what is meant by ripple factor means, so here whenever this value is converted into, so percentage means 121%. 121% of the ripple contents are there. So that's why this is also biggest disadvantage in half wave rectifier. So this is also biggest disadvantage in half wave rectifier. So now here efficiency is less and here ripple factor is also more. Ripple contents will be more. So that's why this is the, so this is not suitable for practical application. So this is not suitable for practical application. Now coming to the TUF, so transformer utilization factor. Now we are using transformer. So which type of transformer we are using? Step down transformer we are using. So this step down transformer, so here whenever here how much of percentage, so that will be utilizing means, so 0.286% of the, so that will be utilized. So 0.28 means, so 28.6% of the, so here the transformer is only utilizing. So here utilization of the transformer factor is also very less and here ripple factor is also more value, so and efficiency is less. So here that's why here this half wave rectifier is not suitable for practical application. So how to overcome? So next one, it is nothing but a next one, so that is full wave rectifier. So now here full wave rectifier means, so previously in half wave rectifier how many diodes we are using here? Only one diode we used, so in half wave rectifier. So now in coming to the full wave rectifier, so now we are using 2 diodes. Okay. Now what is the disadvantage in half wave rectifier? Efficiency is less, only 40.6% of the AC input power is converted into DC and ripple content is also more. Ripple factor 1.121% of the ripple content is there and what are the TUF? So transformer utilization factor, how much means? So that is 0.286 means. So transformer is also utilizing only 28% only. So that's why efficiency is less. So the disadvantage how to overcome means. So next one is nothing but a full wave rectifier. So full wave rectifier means. So full wave rectifier means. So these are the, so previously only one diode we used. Now here we are using two diodes. Okay. Now here two diodes we are using. Now here two diodes means. So now two diodes. So now here two diodes means. Now here we are using step down transformer. So now here we are using step down transformer. So now two diodes means. So here we are using a center tap transformer. Previously step down transformer we used. Now here we are using center tap transformer and two diodes. Whenever here AC input power, so this AC input power is applied to the, so this center tap transformer. So what is that one? So this positive going pulse coming to the here center tap transformer means. So this voltage level is decreased here, that will be applied to the, so now here positive diode. Okay. So this positive cycle if you apply to this, so this diode, positive cycle if you apply to the diode. So now whenever positive cycle if you apply to this diode means, so this diode will be conduct. So this is the output. Now coming to the negative of cycles, whenever this is positive and here this will be negative. Positive and negative means, so negative going pulse means, so here this diode will be on. So in positive going pulse D1 diode will be on, in negative going pulse, so D2 diode will be on. So D2 diode will be on. So D2 diode will be on means, so here positive that will be on, negative that will be off. So what is meant by center tap transformer? So what is the operation of the center tap transformer? Now here one diode, here also one diode. Now this is nothing but a load resistance RL. Now what is the operation of this one means, whenever if you apply AC input power, so here positive going pulse means, so this is positive and negative and here positive and negative. In the positive going pulse, so here this diode is terminal is positive. So now this is the output across the diode D1. Now coming to the negative going pulse means, so here negative going pulse means, so here what happened negative going pulse means, so now here this is nothing but a negative, so here this is nothing but a positive, negative and positive. Now coming to this diode, so now this diode, so this is negative here means, so here what happens, so coming to the negative of cycle means, so now again here this diode will be on. Okay. So now here what is the D1 diode output? So D1 diode output means, so here this is the D1 diode output. Okay. Now coming to the D2 diode output means, so now here what is the gap is there, so in that gap, so here the diode will be on. Okay, D1 diode and D2 diode. So now complete what is the output of the here full wave rectifier? So this is the full wave rectifier output. Why this type of output means? So now we are using two diodes. Okay, now we are using two diodes. One diode it will be on one time. So again here if you apply negative going pulse, so here another diode will be on. So this is the output of this one. Okay, output of this one. Now here output of this one means, now same thing. So now here this is output of this one, output of this output. Okay, full wave rectifier output. So now here same parameters we can calculate. So here VDC of this full wave rectifier and here V RMS value. Previously in half wave rectifier, what is the value of the VDC and what is the value of the VRMS? So what is the half wave rectifier output means? So that is nothing but a half wave rectifier means, so that is nothing but a Vm by pi and here VRMS equal to Vm by 2. But coming to the full wave rectifier, so here what is the DC voltage means? So 2 Vm by pi. Okay. Now here this value is Vm by root 2. Vm by root 2. Now here VDC equal to Vm by pi and VRMS equal to Vm by root 2. Now coming to the here, what is the efficiency of this of full wave rectifier? What is the efficiency of this full wave rectifier. So what is the efficiency means how much here DC power output by how much AC power input. So how much value means, so what is the efficiency means DC power delivered to the load by AC input power, AC input power, that is nothing but efficiency. Okay, how to calculate the efficiency means, so here, so now what is the DC power means, so again here this is nothing but a PDC, again here this is nothing but a PAC, okay, PDC, PAC. Whenever if you simplify this one, so this value is 0.81. PDC means how to calculate PDC, PDC equal to, again here how to calculate PDC, PDC equal to VDC into IDC, VDC into IDC. Okay, now here DC power equal to V into I. What is the efficiency of the full wave rectifier? So this is the output of the here full wave rectifier waveform. How to calculate the efficiency? So how to calculate the efficiency of the full wave rectifier? Efficiency means how much of DC power delivered to the load and how much of here AC input power. So whenever here how much of DC output power at the load, DC output power, and here how much of here AC input power, AC input power. How much of DC input power and how much of AC input power means what is the efficiency of this one means. So DC output power means PDC. So PDC means again here that will be VDC into IDC. So and again it will be converted into, so here IDC means, so IDC means VDC by RL. Whenever if you substitute that values means, so what is the efficiency means, so that is 0.81, that is the efficiency. So 0.81 means, so that will be converted into percentage means, so 81.2 percentage of the AC input power is converted into DC. Okay, so this is the advantage. So this is the advantage. So how much of here efficiency of the half wave rectifier? That is only 40.6 only. So that is only 40.6 percentage of the AC input power is converted into DC. But in the full wave rectifier, 81.2 percentage of the AC input power is converted into DC. Now coming to the here ripple factor. So ripple factor means, so here how many AC ripple contents are there? How many ripple contents are there? So now here how to calculate the ripple factor? So VRMS by, so VDC by VDC whole square minus 1. So this is the formula of the ripple factor. VRMS means Vm by root 2 and VDC means, so 2 Vm by pi. Whenever that values if we substitute, so what is that value means? So that is 0.48 only. So 0.48 means, so this is a less value compared to the half wave rectifier. So this ripple factor value is very less. 0.48 percentage of the ripple contents are only there. Now coming to the here TUF, so transformer utilization factor. So previously how much of transformer utilization factor? So that is only 28.6 percentage. But whenever in the full wave rectifier, so that will be increased to 63 points. So here 4. So how much of transformer is utilized? So 63 percentage transformer, so that will be utilized. So here transformer is utilizing 63 percentage means, so that's why efficiency is high, and here now ripple content is less. So that is the advantage of the, so that is the advantage of the full wave rectifier. Now full wave rectifier. Next, but here what is the disadvantage of this full wave rectifier? What is the disadvantage of this full wave rectifier means? What is the disadvantage of the full wave rectifier? So transformer is, what is the disadvantage of the full wave rectifier? What is the disadvantage of the full wave rectifier? We are using center tap transformer. Now we are using center tap transformer. So now we are using center tap transformer means, so that is costly. So center tap transformer means, so that is costly. So that's why here to overcome that problem, so now next we are using bridge rectifier. So to overcome that problem, so next we are using bridge rectifier. In the bridge rectifier only here, in the bridge rectifier only how many, so in the bridge rectifier totally we are using 4 diodes. In the bridge rectifier we are using 4 diodes. So now here we are using only step down transformer only we are using. So what is the disadvantage in full wave rectifier? So disadvantage of the full wave rectifier, now here center tap transformer we are using. So that is the biggest, that is costly. So that's why to overcome that one, so now we are using, so this one, to overcome that one we are using this one. Now here what is the advantage of this one? Same efficiency. Now here same efficiency. So how much of efficiency means? So that is same. How much of full wave rectifier efficiency? So now same efficiency. Now we are using same efficiency. So how much of here? How much of here? That one means, so 81 point. So here 2% of the same efficiency. Now coming to the here. So same efficiency, and here ripple content also here that will be less only 0.21%. So here, so ripple content is also that will be less. So ripple content is less. So ripple content is less, and efficiency is increased. Efficiency is increased. Efficiency is increased. Now ripple content and efficiency increased means, so here compared to other rectifiers, so here full wave rectifier, bridge rectifier is advantage. So bridge rectifier is advantage. So now here bridge rectifier advantage means, so here, so 4 diodes we are using, right? 4 diodes we are using, 4 diodes, and here same efficiency. So bridge rect. So now here coming to this, so this is nothing but a resistor. So now what is the output of the half wave rectifier? So this is the output of the half wave rectifier, alternating current into, so here pulsating DC. So what is the internal structure of this one? So what is the internal structure of this one means? So this is nothing but a PN junction diode. Okay, internal structure PN junction diode. Yep. So this is nothing but as output. How that will be generated means, so here positive, if we apply the positive input pulse to the transformer, according to this, what is the output of this one means, positive going pulse means, so the diode will be on. So the diode will be on. So this is the output. So positive going pulse. So here this diode will be on. So this is the direct current. Now coming to the full wave rectifier. So what is the full wave rectifier? What is the output of the full wave rectifier? So now full wave rectifier is also, now if you apply positive and negative going pulse means 2 diodes we are using. So one diode in the positive going pulse, diode D1 will be on. In the negative going pulse, so diode D2 will be on. So this is the output. D1 will be on and D2 will be off. D2 will be on. So at a time, see here, one diode it will be on, one diode it will be off. So now this is the full wave rectifier output. So totally complete is nothing but a full cycle. So this is nothing but a full cycle. Transformer, diode D1 and diode. So this is the output of the full wave rectifier. Positive going pulse, so positive one diode, D1 diode will be on. In the negative going pulse, D2 diode will be on. So this is the output of the full wave rectifier. So this is the output of the full wave rectifier. Now coming to the next, bridge rectifier. In bridge rectifier, how many resistors, how many diodes we are using? One resistor and 4 diodes. One resistor and 4 diodes we are using. So why we are using bridge rectifier? What is the disadvantage in full wave rectifier? So center tap transformer here we are using. So that is costly. So to overcome that problem, now we are using bridge rectifier. So now we are using bridge rectifiers. How much of efficiency of the bridge rectifier? So now here same efficiency. Okay. So here that is nothing but the same efficiency. In the bridge rectifier is also same efficiency. How much of efficiency means 81.2%. So now here full wave rectifier. So one diode will be on, positive going pulse, in the negative going pulse. So here one diode will be off. So now here also next here we are using 4 diodes, bridge rectifier, same output, same efficiency, and the ripple content is also less. Ripple content is also that will be less. So this is nothing but a bridge rectifier. This is my topic. So thank you very much.